Okay, so for our segment on stoig or stoichiometry calculations, we start with question 8, where they give you a chemical composition of unknown values, and they say that X in that chemical composition represents the amount of carbon atoms, and then they give you the percentage of oxygen, and they want to know what's the percentage composition of only the carbon. Okay, so this is a bit of a lot of writing. So question 8. So this relies on your math skills. So for question 8, you should know that if we have this composition, and for oxygen it's 12.5%, we can go and calculate just with that the total molar mass or molecular mass. So the percentage oxygen, we would have calculated it to be 32 over, because it's two of them, two oxygens, over the molar mass, and then multiply that with 100. Okay? So if we do this and we change, well, we have the percentage oxygen to be 12.5, 32 over m times 100, and then if we get m to be 256 grams. Okay, that is the easy math on that. That means for this whole molecule, the molecular mass for this whole molecule is 256 grams. Okay, so that means, I'm going to do this now in green here on the side, that means that 12 times x, okay, carbon is 12 on the periodic table, plus 1 times 2x plus the 32 for oxygen should all equal the 256, okay, the total molecular mass. And that just changes to 12x plus 2x equals the 256 minus the 32 to be 224, okay. And then if we find what x's value is, it's 16. Now that is just the factor that represents x. Okay, that means this molecule is actually C16H32O2. And then if we go and calculate the percentage carbon, we have 16 times the molecular mass on the periodic table over the total molecular mass times 100. And then we get the percentage carbon to be 75%. 75% carbon, and that correct answer is then A. Okay, a bit of math, but it's not difficult if you remember your original formula for percentage composition. Then question 11, we have a zinc chloride reaction. It's already balanced. I'm going to do it here on the black. They say that we have original mole of 7 for the HCl and 8 of the zinc, and then at final value we get that the moles of the ZnCl2 to be 2 moles. Okay, so then we just draw a small little table for all 3 or 4 of our different things. We have Zn 2 times HCl, ZnCl2, and then H2. Okay, is it ZnCl2? Just want to check. Yeah. Okay, and then we have our initial, our change, and our final, and they just basically want to know what is the final moles of our 2 reagents. Now remember, products is a 0 in the beginning, okay? And they have that is 2 because it's given, so that was plus, meaning in a stoig ratio, if our initial mole of zinc was 8 and our initial mole of HCl was 7, in a stoig ratio from 1 to 2 to 1 to 1, we have that the reagents will be subtracted, okay, and it's 2 and 4. Why can I say that? Because that final mole of our H2 that was given is basically our stoig ratio now. So 8 minus 2 gives us 6. Oh, 6. My board's getting slow. And 7 minus 4 is 3. So our final moles, sorry for that, our final moles for Zn and HCl is 6 and 3 moles, and that will give you option B. Just want to clear this. Will be then option B. All right, then our last question for stoig is number 12, where they say we get 13.93 grams of zinc, and this has the same amount of particles. Now remember, you don't need to go through all the equations for mole, because if you have the same amount of moles, then you will have the same amount of particles. Okay, so what I went and did here on my whiteboard, sorry, just want to get that. What I did is calculated the moles of the zinc. Okay, that's Zn. So the mass of zinc was 13.93, the molecular mass is 65 on the periodic table, so we need to get a moles of 0.21. So I just went on, I didn't even compare calcium, you'll see why, and we got the masses of each. The iron to be 12, the mass of nitrogen 3, and that of sulfur to be 5, and then comparing that and calculating the moles. So if we calculate the moles of sulfur, it's 32 on the periodic table, then you get a value of 0.16 moles. Nitrogen, because it's a diatom, it's 28, so the moles will be 0.42, and that's still not equal to that of zinc, but iron is 12 divided by 56. It's 12 grams, 56 on the periodic table, and then you get 0.21 moles. So equal moles means equal amount of particles, thus option B will be your correct one for this answer or question.